Hi guys, this is lesson 2.4 in Algebra, and I want to go over this lesson because it uses that geometric meanies a little deeper, a little more challenging way of it. So to start with, I'm going to go through this first page, just kind of walk you through the notes. So now we're talking about those continuous exponential functions. And we're going to talk about the ones that kind of fill in the numbers between the values like 2 and 2 to the second and 2 to the third. So we mostly use whole numbers for exponents at this point. Now we're going to go the ones that go in between, hence the name in-betweeners. So let's start with this function. F of x is 4 times 2 to the x power. Let's fill this in, these boxes here, with the answers. So we know what this function should look like putting in whole numbers. So I'm going to use yellow and to use some pink. And just a reminder of how this works, it's f of, I want to put in a 1, equals 4 times 2 to the x power, which in this case, we don't want x because we're going to fill in the 1. So we're going to go to the first power. 2 to the first is 2 times 4. 8 goes in here. That is a really bad 8. There. So now I'm going to put a 2 in here for the second one. 2 squared is 4 times 4 is 16. And notice it's a times 2 as I'm going across. 4 times 2 is 8. 8 times 2 is 16. So I'm going to do a times 2 here and do 32 and 64. So now that I've got these first ones on here, it says plot these points on the graph at the end of this task so that we can see what this graph is supposed to look like. So I'm going to scroll down to the last page here, and my graph is kind of rough since it's the copy. But anyway, so the drawing in the green, since I did those in green, it said number 1 was 0 was 4, 1 was 8, so that's going to be about right here. Now I got to zoom in on this one so I can be accurate. I'm going to zoom in. So 1 up to 8 is about right there. 2 was 16. Those go right there. 3 was 32. If I can reach it on here. 3 up and over to 32. I'm going to erase that one and make that slightly better. I can see my line for 3. 32 comes over about right here. And 64. So here's my line. I'm just going to draw a little bit of a line here so I know where I'm going with it. 64 is way up here. So I'm going to continue up this green line till I get to about 64. And I'm going to go ahead and erase that guy. Okay, so zoom out so we can see that is kind of our path of the line. So that's what we're trying to see. What's going to follow in that line if we go in between? So if we read through this next section, it says, let's say we want to create the table with more entries to see about what's actually in between those dots. Travis is saying if it goes up by 1, then half that growth occurs between 0 and 1, and the other half occurs between half and 1. So you can kind of find the average of the two numbers and be able to fill in the gaps. So we're going to fill in the ones we originally had. So this was an 8, 16, 32, and 64. And so what he's saying is, I'll use pink, 4 to 8, so kind of the arithmetic way of it, there's 4 between them, so half would be 2, and that puts us at a 6. 8 and 16 are 8 apart, So halfway between them would be 4, so that makes this as a 12. 16 and 32 are 16 apart. Halfway between that is 8, so that puts us at 24. And these two are 3 and 4 are 32 apart. Half of that is 16, so 32 plus 16 is 48. So that's what Travis says, what we need to do. And let's plot these. So it's 6 should go in between 6, 12, 24, and 48. So in pink, I'm going to do one, let's see, half was 6. 1.5 was 12. 2.5 was 24. Oh, that one seems a little off. Those two don't seem too bad. And 3.5, which is kind of this darker line here, was at 48. So if I can keep track of that line. And 48 is about right here. Oh, I didn't put my, where's that? 348. It's about right here. So I'm going to zoom out again. Kind of off, but if you notice this one, the pink one here and the pink one here are not quite really in that path going up with the green. Those two aren't too bad, but as we're going up higher, the pink ones seem a little off. So that's what Travis says we should do. I think that was the end of his. Yep. So we just commented on that. How does it compare with that first one? Well, fits on the lower ones, not so much on the big ones. So Miriam says, I think we should fill it in the geometric meanies way, because if it gets farther apart as it gets bigger. So the halves should show that as well. So I'm going to go ahead and fill in my 8, 16, 32, and 64 of the originals. And now let's use the geometric meanies way. I'm going to do that in purple to fill in the half here. Well, and this time I'm going to divide. So 8 divided by 4 is 2. And I have 1, 2 jumps. So I need the square root of 2. So that means I want the square root of 2 every time I do a jump. Well, 4 times the square root of 2, I want to keep my number exact. So at this point, that is all the further I can go when it comes to putting it on for my table. Well, if I do this again, 4 square root of 2 times square root of 2. So I'm kind of running out of space here. I'm going to scroll down just a little bit more. So I have a little space to work here. 4 square root of 2 times the square root of 2. Well, 2 square roots, how do I even multiply those together? Let's take a number we know. Square root of 9 times the square root of 9. Well, the square root of 9 is 3 times the square root of 9 is 3. 3 times 3 is 9. So basically, when you multiply 2 square roots together, you have just now canceled out the root, and it's the number underneath that is your answer. So in this case, the 2 square roots cancel out, and I'm really just taking 4 times 2. So 4 times 2, which gives me 8. And if you notice up here at the top, that's true. When I jump 2 spots over, I end up with 8. So if I had cubed roots, I would need 3 to cancel out. Fourth roots, I would need 4. So let's keep going. We have the square roots here. So again, I'm going to multiply by a square root of 2. So this would be an 8 square root of 2. And keep going. Times square root of 2. Those 2 cancel. I'm at 16 again. 8 times 2 is 16. 16 square root of 2 times 2. Those cancel. Just 16 times 2. And 32. I'm running out of space here. Let's see if I can get this. If I can get this to fit in. 32 square root of 2. Then I get 64. So now I'm going to put these on the end on my graph. But what I have to do to be able to do that is I actually have to figure out the numbers for it. So I'm going to pull up my calculator here on my phone, and I'm going to scroll down. And 4 times square root of 2, 4 times the square root of 2 equals 2 square root times 4. 5.6 about. So in purple, we're going to do half is about 5.6. So it's really close to that pink one. Now let's do square root of 2 times 8, 11.3. So this one should be at about 11.3, so just a tiny bit lower. How about square root of 2 times 16? That should be 22. Ooh, now we're going a little bit lower on here. Oh, that's kind of more in the line of the green, isn't it? And then square root of 2 times 32. It's about 45. So I jump over here, 45 on this line, there we go. That's about right. So I'm going to zoom out again. Notice how my purple and green seem to be lining up better than my pink and green. So those seem to match better. All right, let's come back up here and see what this second part is saying. So what if Miriam wanted to find the values for the function of every third interval instead of every half? So we're trying to get more dots in between the 0 and 1, 1 and 2, 2 and 3. So again, I'm going to go over here and fill in that this is 8, this is 16, and this is 32. Well, same process as we did before. We're taking the division and then how many jumps we have. So this time I'm going to use blue. So I'm doing 8 divided by 4 again, which I still have a 2, but now I have 3 jumps. So I'm going to do a cubed root of 2 this time. So here is going to be 4 times the cubed root of 2 is 4 cubed root of 2. Don't have a whole lot of space on here. Sorry for the cramming. And now we're going to do it again. Times the cubed root of 2. Well, just like we had down below, I'm going to actually erase these so I can use them again, trying to show you the options. So when we're doing this, 4 times the cubed root of 2 times the cubed root of 2. Now, I can leave it just like this because I need to have 3, right? We said over here with the square roots, we had to have 2. Well, because this is a cubed root, I have to have 3, and I don't. So I can either leave it just like this, or I can say 4 to the cubed root of 2 squared. So either one of these would go into this spot right here. And same thing with the others. The first one would be 8 cubed root of 2 And then the next one would be, I'm going to give myself some space here, 8 cubed root of 2. And I'm going to do this squared on this one since I don't have a lot of room. Because when I go for my third one here, as I'm going one more time, now I have, let me get another color, 1, 2, 3, and make that a 2. 3 of them will make the whole number of 2. And now I can multiply by 2 to get my 8. Multiply by the 2 to get the 16. So let's go ahead and finish out these. 16 cubed root of 2. And then this one is 16 cubed root of 2 squared. And so if I were to plot these on the graph, they would fall into that line with the purple and the green. So now I got to erase a little bit so I can see my problem here. This one actually should be a 5, and this one should be a 6. So what number did you use as the constant factor to compare in the problem in table 5? So up here, we multiplied by square root of 2. So I'm going to go ahead and mark that. This is a square root of 2 is what we used for problem 5. And so for this last one right here, problem 6, we used cubed root of 2. I'm going to throw that color in here. So for 6, we used the cubed root of 2. Now give a detailed description of how you would estimate the output of f of x for x equals 5/3. Well, if we look at this one right here, notice it's 4, and then over here in our parentheses, we have cubed root of 2 squared. Well, that filled in for the 2/3 power. So this number, the exponent, becomes our numerator, and the 3 on the bottom, the third, or our root, becomes our denominator. So if I take that rule and look at 5/3, I'm running out of space. I'm going to go over here. So my numerator is the power. So 5 must be my power. And I know it's a root of 2. And the denominator, the bottom number, is 3. So I'm going to put that as my root. So this would be, if x equals 5/3, yeah, we'd start with the 4 because that's what we've started with every time. The 4 for our first thing. Well, not necessarily. But it would be, let me erase this for the moment. The 5/3 would fill in like this. That's what that would mean. You're taking, yes, no, I was right with the 4. I don't know what I was thinking here. So 4, because if I did 4 to the 4/3, that would be one of the 2's multiplied by the 4 as well as others. So we'll get into this part right in here a little more detail later. But the one thing I want you to recognize with it is the fraction matches up with the root and the exponent. So numerator is the exponent, denominator is the root. And then our last piece was this. So our blue ones would have followed in with our green and purple. Hope that makes sense. Please let me know if you have any questions as you're going through this. Thanks.